We are back on the PDF for the Computer Science and Digital Fluency Learning Standards. I'm on page 13, which starts the beginning of computational thinking, which is our next video. Again, remember you can do these standards in any order in your PE classes or in your health classes. We're just doing them in order to keep it a little easier to follow along. Please take a moment and read the information at the top of your screen as far as what computational thinking is. But truly what they're saying is computational thinking is problem solving. It's critical thinking. It's thinking about how we analyze our data, how we look at simulations. We think about variables and algorithms for different things that we do. And this is definitely something that can easily be incorporated into a PE or into a health class. So let's take a look at the 4 sub-concept areas, which were reviewed in that first video on this module. But just to do a quick review again, we have modeling and simulation, data analysis and visualization, abstraction and decomposition, and then algorithms and programming. As I scroll down to page 18 of this PDF, you'll note that computational thinking has 10 standards. This is the largest area of standards here on the for these computer science and digital fluency standards. So this is something you're definitely going to want to take a look at here as you're thinking about how you're going to roll these standards out. You'll note that there's only one standard for modeling and simulation. There's 2 standards for data analysis and visualization, and 2 standards for abstraction and decomposition. But you'll note that the largest area within this concept area is algorithms and programming. And while we often think of this as coding, there's lots we can do within our classes to make sure that these concepts are being done even without touching computers. So we're going to take a look at some of those as well as we go through this course. We're going to scroll down to page 24 of the PDF and look at these standards. Again, I highly recommend that you take a moment to read through these, especially the grade bands that you teach. But we're going to go through just the overall or the overarching idea that happens within each of these concept areas. So within computational thinking, the next concept area we're going to talk about, our sub-concept area, is this modeling and simulation. Here we're thinking about patterns and think about what we can do to fix that. If you're thinking about breaking down how to do a free throw or how to do an outside hit in a volleyball game, you might think about the pattern that we would go through. You might have the students practice that motion over and over again to make that pattern be something that's more innate in them. Same idea here. We're thinking about creating that model. We're thinking of that system that we're going to show for those step-by-step procedures. Those step-by-steps then will tie in very nicely to algorithms as we get later on in these standards. As you move into the upper grades, we're thinking about modeling this and thinking about how input and output could change. For example, if you were doing that outside hit in volleyball, you might note that the students need to take a step back in order to get the right amount of steps in. Or maybe they need to shift to the right or the left, and how that changes their success rate on hitting that ball over the net. So that is definitely something that you can think about and just start to identify ways that you use the data to improve athletes' performance. As we move into data analysis and visualization, you're thinking about identifying how data can be collected and actually collect that data and then evaluate it. We do this a lot when we take video at sporting events, or you might have the students write down their heart rate after certain things that they're doing in your PE class. They may be writing down the foods that they eat in a health class to be able to evaluate their caloric intake. So you can think about sensors. You can think about using data in different ways, whether it's spreadsheets or charts or surveys, videos, and all those kind of things when you're thinking about how you're going to collect that data. Continuing on with data analysis and visualization, you're thinking about ways that you can make that data visualized. So you might think of making a chart or sorting the data in certain ways. Maybe thinking about using software that can help organize large data sets to give you some data stories. As we move into abstraction and decomposition, you're thinking about identifying problems and tasks and breaking them down into smaller parts. So really here again, if you were thinking about how to do the perfect layup, you might break down the steps that need to be done, where your arm should be, how your shoulder should be, and so on, as you're thinking about how you're going to make sure that that layup is successful. As you're moving through from kindergarten to ninth grade, we're really thinking about those functions to organize it. So it might be using something, again, to be able to break down those parts. So it could be slow-mo, it could be looking at frame by frame in a video or something along those lines. As we move into abstraction and decomposition, you're thinking about the things that you need to make sure that you are successful in what you're doing. So, for example, going back to volleyball, if you were going to hit a ball over the net, what are the steps that you do? What are the simple things that maybe are extra that you might do? Maybe you turn your wrist a certain way. We need to correct that or something along those lines. So, you're going to decompose to figure out the best input and the best output. And then we'll move into algorithms and programming. And really, this is a step by step procedure. We do this a lot as we teach anything in our PE classes. We're thinking about what we're going to do to be successful. So, you're going to teach your students how to hit a baseball, how to walk around or run around the baseball diamond, where to hold the glove, and the different steps that you would do to throw a ball. So, all of those kind of things can be algorithms. It's a step by step process. This can be done by having students break down things that they do. Maybe they can create how-to videos of the sports that they like. As we continue on in algorithms, we're going to identify the values over time. So we always talk about like word of the week or today's date, today's weather. That could be something you're doing with collecting data. You know, maybe the first time they ran a mile, they did it in 12 minutes. The next time they got down to 11 and a half and so on to hopefully get down to a much faster time. And then as we get into the upper grades, we really can think about variables. So what would change something? How would what we do be different based on what's in front of us or the information and how it's shifted? As we get into algorithms and programming, computational thinking standard 8, we're talking about, again, identifying a task that consists of steps and what steps need to be done and what happens if you remix a part of that to be able to look at being successful in something. The last two are thinking about fixing those bugs in your algorithm. So if the student is doing something and every time they do it, something in the same amount of steps, something doesn't happen quite what they want, maybe it's taking a look and fixing something. Maybe it's the way they step or the way their thumb twists on a golf club or something along those lines that can change something. And really you're thinking about debugging their stance or their throw or their hit, whatever it happens to be, that can still be thought of through computational thinking. And then finally, we're actually going to do the steps. So like I said earlier, you could have the students create how-to videos. You could have the students explain to another class, maybe have your upper level students help a lower level or varsity help your JV to be able to break down different things to make it more achievable and help your students be more successful.